In this video, we will learn how to use Excel to find the confidence intervals for variance and standard deviations. We need to use the chi-square distribution when calculating the confidence intervals for variance or the standard deviations. Recall that the variance is just equal to the standard deviation square. For variance, the confidence interval formulas for that is below. The lower bound would be n minus 1 multiplied to s squared divided by the chi-square, the right chi-square. And then the upper bound is n minus 1 multiplied to s squared and divided by the left chi-square. N is just a sample size. The degree of freedom is n subtract 1. And S here is just the sample standard deviation. And then for the standard deviation sigma, we just have to take the square root on both sides because the variance is the standard deviation square. So to find the standard deviation, we just take the square root of the variance. Okay, how do I find the left and the right chi-square? This value and this value. Okay, so we have the functions. So now we are given the area. We can find the left and the right chi-square by using the inverse chi-square function. Again, on the left tail, we have alpha over 2. And on the right tail, we also have the value of alpha over 2 for the area under the curve. The left chi-square is from the left side and the right chi-square is coming from the right side. So for the left chi-square, we simply use the chi-square, chi-sq stand for square. So chi-square dot inv inverse. So this function returns the inverse of the left tail probability of the chi-square distribution. And then to find the right chi-square, we use the chi-square dot inv, but then again we put another notation rt. So chi-square dot inv dot rt. Rt stands for the right, okay, the right side. So this function here returns the inverse of the right tail's probability of the chi-square distribution. So left, we don't have anything attached to it. But for the right, we have dot RT. Okay, so there are 5 steps to construct the confidence interval for the standard deviation sigma. We find the sample standard deviation S. This is simple. We just use the regular stdev dot S to get the sample standard deviation of any data set. And then to find the chi-square of the left tail, we use the function chi-square dot inv, and then we input the area, which is alpha over 2, and then comma the degree of freedom n minus 1. And then to find the right chi-square over here, we use the function chi-square dot inv dot rt right, and then alpha over 2, and then comma degree of freedom. And then to find the lower bound, we just simply take the square root, right? The square root. So sqrt square root of the degree of freedom. This one, n minus 1 is the degree of freedom. Multiply to the s square, which is the sample standard deviation square, and then divide by the chi-square from the right. And then for the upper bound, we do the same thing, but then we divide by the chi-square of the left tail. Okay, example. We are looking for the 95% confidence interval estimate of the population standard deviation of these values. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So n is equal to 12 in this case. It is 95% confidence interval, so alpha is the other 5% or 0.05. And therefore alpha over 2, half of it is 0.025. Okay, So first thing is we need to enter the number, right? We need to enter the number in one column. So 62 all the way to the last one. And then n is equal to 12. And then the degree of freedom, of course, is n minus 1. So 12 minus 1, it is 11. Okay, it is 11. Now, let's try that on Excel. All right, so we need to find the S value. So we have the degree of freedom is 11. The S value with the sample standard deviation should equal STDEV dot S and opens. And then we drag everything inside and we close it. So that is my standard deviation S. And next, we need to find the left chi-square, right chi-square, right? Left chi-square, left chi-square, and the right chi-square from the formula. Okay, for the left chi-square, we just simply use the chi-square dot INV because I'm looking for the inverse chi-square. And the probability, that is the level of alpha over 2. And alpha over 2, remember, it is equal to 0.025. And the degree of freedom is 11. You can just press here or type 11, right? And that should give you the left chi-square. For the right chi-square, we use the chi-square dot INV and then dot RT, the right hand side. And then we input the alpha over 2, the probability, and that is again 0.025. And my degree of freedom again is also 11. And now I can find the lower bound and the upper bound. Lower bound and the upper bound. So go back to the formula right here. So to find the lower bound, we press equal and we need to evaluate the square root. So SQRT. Okay, the square root of what? The square root of n minus 1, which is the degree of freedom, right? So that is 11 multiplied to s square. So multiply to s square. So multiply to s square means multiply by itself 2 times. So multiply another one. And then divide by the chi-square from the right, which is this value. And then we just close it. And here is your lower bound. Okay? Now for your upper bound, again, we're going to find the square root of s square root SQRT. And we use n minus 1 is the degree of freedom. We multiply to s square. So s multiply to s again. And then divide by the chi-square from the left side. Left chi-square is here. And then we close. And that is your upper bound 6.91.